peptide shifts up to the cell surface. Okay, so you can imagine GLUT4 moving from the recycling compartment to the storage vesicle to the cell surface when there's insulin present. Okay, and actually, that storage vesicle is called an insulin-regulated compartment, but that's not important. I just wanted to show you, and I'm not going to ask any questions on the test about GLUT4. I just wanted to show you that in the whole scheme of things that we've been talking about, that's where GLUT4 hangs out. And what kind of cells have GLUT4? Huh? Yep, so the cardiac muscle, skeletal muscle, and fat cells are the predominant expressors of GLUT4. Okay, so that's it. This ends a unit. I probably went through endocytosis pretty quick, but I think you got everything we really need to know. Okay, and there's a couple things that I want you to, that I'm going to have on the test. Some people who've had a course from me before know what to expect. Some of you who've not had a course from me don't quite know what to expect. So I wanted to talk a little bit about those things that you can expect on the test. And I'll give you, we'll have some examples. Is that okay? Is that right to do example questions now? And then later at 7 o'clock tonight, you know, if you've got any unanswered questions, please, that's a great time to get those taken care of. All right, so one of my favorite, it's almost always on page 1. Okay, what's almost always on page 1? Yeah, similarities and differences.
My favorite.
Your
So you're gonna
favorite?
have to time grade those?
Huh?
Is that the one that was on last time?
Yeah. This time there will be. Okay.
You don't have to.
Oh, it's a game. Okay, oopsie. Okay, here's what I want to tell you about this. Okay, and I have a couple of examples here. I took this off the test. It was going to be on the test and I took it off. Okay. You could say, what could you say about the similarity between these two? Huh? They're docking proteins, right? You could say they're both docking proteins.
That's not really significant.
Huh?
That's not really significant, though, is it?
I would say I would push you for more significance than that. What is it? What is IRS docking onto? Yeah, it is gonna. Itself is docking onto phosphate groups, right? Okay, this is insulin, the insulin receptor. So IRS is docking onto a phosphate group. And it's creating, okay, and it's creating docking sites for other proteins. TRAF is is also binding to phosphate groups. Okay, so TRAC is also docking onto a phosphate group, and it will recruit other things to be phosphorylated by what's the two proteins. Not IRE. Yeah, so I didn't put the endonuclease domain in there. Okay. So TRAC it docks onto a phosphate group, pulls up to be a docking site for a substrate for this protein kinase. IRS docks onto a phosphate group on the insulin receptor, and that thing that docks onto our IRS becomes a substrate for the kinase. And what's the obvious difference here? Yeah, IRS, you could say IRS is docking onto the insulin receptor, or you could even say is docking onto phosphate groups on tyrosines, and is docking onto phosphorylated IRE, but specifically it's docking onto a serine that's been phosphorylated. So you could give me look how much similarity we found. Okay, so if you just tell me, oh, they're docking proteins, there's gobs of things that are docking proteins. Yeah, like I could say, well, Sec12, well, that's kind of but there are tons of docking proteins. So give me more specifics, and we just found a ton of similarities between the two, and an obvious difference. Okay? Okay. Oh, this is ATF4. Okay, what can you say about these? Some similarities. They're both transcription factors, but that's not enough. So P53 and NF-kappa B, and okay, but what?
They're both transcription factors.
They're both what?
Results of the UPR.
Okay, yeah, they are both actually active during the unfolded protein response, and then that would be fine. You could look at what are the similarities between the kinds of genes they turn on. Okay. What are some differences? Yeah, so this actually already exists, okay, in the EMR. But when BIP releases, from ATF6, it moves on to the Golgi apparatus process. This has to be made. Okay, so it's not pre-existing. ATF4 is not pre-existing. It has to be made, and it's made when EIF2 is phosphorylated. Which one turns on the gene for CHOP? ATF4. Does ATF6 turn on any genes associated with apoptosis? No, it doesn't. Okay, ATF4 is is the transcription factor that turns on CHOP, which then turns on apoptotic genes. Okay. So does that make sense? Does that help? Okay. So the clue is to try to figure out why did I put these two things together. Okay. So if you give me like, oh, they're both docking proteins, say, well, so are a lot of other docking proteins. Why did I put these two together? Okay. So keep pushing yourself for the significant similarities, and it's usually the significant similarities that catches you off guard. There tends to be not significant. Here's the other problem we ran into in molecular genetics this time. People were comparing apples and oranges. Don't compare apples and oranges. Tell me if these two, what's the difference between these two things? First, okay, so, and I don't have a good apples and oranges definition. But okay, look, I'm gonna change analogy from, okay. I'm thinking. Okay, so I could ask you what are the significant similarities between these two courses? They're upper level biology courses or something like that. The significant differences, if you said this course meets in the fall, and this course has a lab. Okay, I just compared apples and oranges, right? I don't know what the relationship or what's different between. It turns out, aren't they both true? Okay, so don't tell me things that are both true statements, but you don't get the comparison. Okay. I'm really looking for differences that compare the two. Don't give me two true facts, random facts about the two things I've listed, because I won't count two random facts, even if they are true random facts. Okay? So hopefully that will help you. Oh, we still have time. Any questions about these? You can try coming up with things that, and test each other about these things. Okay, got that? Here's another one that people get mixed up on a lot, and I hate to have people losing points on things that they ought not to be losing points on. Okay. Even at this stage, but I do get it, you have a hard time identifying whether a protein is an enzyme or whether it is not an enzyme. I mean, the LDL receptor is not an enzyme. Okay? It does not catalyze, it does not make or break a bond. Okay? So these guys make or break bonds. And usually, when you think about it, I have to say and. You can't break a bond without making a bond. You don't leave things unbound. Okay? These guys, non-enzymes, don't make or break bonds. Okay? So the LDL receptor and this is really, I've got to say clearly. Okay, so the LDL receptor has no enzymatic activity. It's really a docking site for LDL. Okay, what about the insulin receptor? Where are we going to put that one? Where are we going to put that one? It's an enzyme, right? It auto-transphosphorylates, and it transphosphorylates other proteins that are moved up to the site. Okay, so the insulin receptor is, and we call it a tyrosine kinase because it phosphorylates tyrosine kinases on each other and on the insulin receptor substrate. Okay, so the LDL receptor, insulin receptor is an enzyme. Okay, let's do another one.
I have a question.
Uh-huh.
So like if you were to do a comparison, contrast, you would say a significant difference between IRS and TRAC2 is that IRS for the insulin receptor is an enzyme and like IRE.
No, is this an enzyme?
I mean the
No.
insulin receptor.
Their insulin receptor is an enzyme, but so is IRE.
That's right.
Yeah, but you could have this could be LDL receptor and insulin receptor,
Right.
not an enzyme. Yeah, Suleiman.
Doesn't IRS phosphorylate some stuff?
That what?
The IRS, doesn't it phosphorylate?
The IRS can't do anything.
It does not
It's
phosphorylate?
just a docking site.
Really?
It gets phosphorylated by the insulin receptor. And it becomes a docking site for other proteins,
Okay.
which we will discover in the next few minutes. Proteins that will eventually lead to the activation of AKT.
So IRS wouldn't be in it.
Right, IRS would not be an enzyme. Okay, where would you put ARP? ARP. I put it as a enzyme. Okay, what's its enzymatic activity? It's a GTPase, okay? Where would you put, so we'll put ARP here. An insulin receptor is a good example of an enzyme. How about clathrin? No, it's not an enzyme, so I would put, okay. Okay, so think about what proteins in all of your cheat sheets and flowcharts, which ones have no enzymatic activity at all, and which ones do have enzymatic activity, and when they do have enzymatic activity, try to describe it. Is it a protein kinase? Is it a GTPase? A guanine exchange factor is an enzyme. We'll call it an enzyme. What other ones have we had? Well, we got the endonuclease on IRE, signal peptidase. So think about, and so when we discovered, oh yeah, this thing is an enzyme, what kind of enzyme activity? What kind of bonds does it make and break? And that would be very helpful. So you can list those, so you know, as you're making your cheat sheet. Okay, yeah.
What else do we get cheat sheets for? Because the study guides says we get it for like certain things, but so far from Constance, it sounded like we get it for like everything. So,
Yeah, I'm okay with you bringing, I'm trying to think, is there anything I don't want you to, I'm thinking, is there something I don't want you to bring a cheat sheet for? And right now, I can't think of anything that you can't bring a cheat sheet for. You don't want to be so burdened down with cheat sheets that you're going to spend half your test time flipping through them. Okay, and that would happen if you're not completely very prepared or you're using your cheat sheets as instead of being prepared.
I feel like doing the cheat sheets helps me solidify the information
It
myself.
ought to. The value of the cheat sheet comes before you take the test, not during the test. Yep, I think you're absolutely right. Yeah, perhaps.
On the cheat sheets, for like the mannoses, can you put mannosidase 1 or not?
You can do it's the name of a protein.
Is that a, okay.
It's a, yeah, so it's an enzyme. Is it an enzyme or a non-enzyme? Yeah, it's an enzyme, so it's the name of a protein. You can put that down, like you can put down EDAM. ERAD, just remember, is not a protein, it is a process. So be careful about that. Don't, if I ask you to list a protein that has, I don't know, some sort of a function, removes a carbohydrate, don't put down ERAD, it's not a protein. Oh, speaking of which, yeah, so I'm saying that you can have a cheat sheet on anything, and the reason, you know, mainly because this is a lot of stuff to memorize. It's a lot of stuff to memorize. And I want to take memorization out of the equation because it's not going to help you. I'll have a couple spit back questions where all you have to do is spit back information from your cheat sheet, but there's going to be a lot of application questions because you now have cheat sheets. And it is a perfect way of preparing.
And the only thing that we had to know on our own was the, 13.
Some like boundary arrangement from the Camtasia.
Yeah, the only thing is that, right, the Camtasia thing. Yep. Okay, I got another question. Another kind of question, this is page 2. So we got through page 1. Okay, so here's the other thing that I will do. You're gonna be listing proteins with certain characteristics, okay? So I'm gonna give you some characteristics. Okay, so of all of the proteins that you have on your cheat sheets, which proteins are transcription factors? ATF4, ATF6, we already covered those. Okay. What? What else? Cha. What else?
XBP1.
Yep.
June Foss.
Yep. FB, okay, FBP, and somebody said June bus. Okay, good. Okay. Here's the thing that just like, oh, no. If you list non-protein things, that's a bummer. And every test, somebody, or groups of somebodies, will list non-protein things, like glucose. Imagine that, you know. And I get it, under stress, that can happen. But just remember, do not list GTP, it is not a protein.
But you have a certain amount that you want us to list.
Yeah, the number of blanks tells you how many proteins you have to list. Okay, here's another one. Okay, how about some carbohydrate modifying enzymes?
That's true.
Okay. Carbohydrate modifying enzymes.
Are you now like mannose and glucose?
So mannose, the glucosidase, 1.
Oligosaccharide protein
Huh?
transferase.
The what?
The
one?
oligosaccharide protein transferase, does that count?
You know, I would count that one too.
Okay.
I would actually count that too. What's another really long name one? N-acetylglucosamine phosphotransferase. The one that senses misfolded proteins. Okay, one of the carbohydrate one. Good, because goal. Glucosylase glucosyl transferase. Okay, is also a unfolded protein sensor that will put the glucose back on so it can run through the protein can run through the Cal-Nex and polypeptide cycle again. You could put down Edom. I would even include Edom. Okay, here's one. Okay, we got our last one. Yeah, so what kind? So name some proteins. You can't say that. Name some proteins. Translocons, great. Huh? IRE and PERK would fit into that category.
Signal.
ATF6 would not. That was good.
Project 53.
Urgic 53 actually has KKXX. Mm-hmm.
What about like Q1? Like Q1, within like the ubiquitin ligase stuff.
Oh, yeah, that could. You're missing some other really important things. But they're ancient, but it's like, oh, we covered those about a month ago.
Oh, that's yeah.
Well, calnexin would be a great one. Okay, farther back, like it seems like you were 3 when we covered it.
Like signal peptidase.
Signal peptidase is a great one.
Yeah.
Where's
It's the SRP receptor.
SRP receptor? Okay, and parts of the oligosaccharide protein transferase are transferable also, but I wouldn't expect it. Okay, so does that tells you now, you know what's on page 1 and you know what's on page 2 of the test. Okay? But obviously, I'm not gonna use these characteristics, but you can probably come up with characteristics on your own. You could probably come up with some compare and contrast pairs also, that you can use with one another. Yep. Okay, so,
Is it 7 up there?
is what?
Absolutely.
Yeah, 7, we're gonna try to be up there in our regular, the one that, where the good times are. The place where you're gonna be doing all this.